Okay, great. Welcome to everybody that has joined so far. We're just going to wait a few more minutes before we start officially. So just hang in there. So we're just testing some last few things that see there's still a few people joining. I don't know if you guys can maybe get some notepads and to make notes. So get yourself a pen and notepad to make some notes during the webinar, and then as soon as you're ready, hopefully we'll be ready, and we'll get started. Great, some good chats coming in. Welcome, everybody.
Hey, so I think we can already answer the first question. So that is asking if the recording will be available at the end of this presentation.
Yes, definitely. It will be sent to you via an email link after we're done. But please still make sure to stay till the end. There's a little surprise.
Okay, perfect.
Okay, it looks like we're ready to go. I think we've given enough chance, but everybody can join. So if you lose connection, please don't worry. Just re-click on your link and join us again in the webinar as we continue. Awesome. Thank you so much. Great. So welcome, guys, to this webinar on how to create an accurate 3D model using your phone. So I trust you're just as excited as us about this webinar. And I think before we get started, I'm just going to introduce two of our co-hosts, Leon and Vid. Vid is from 3D Survey and Leon is from Some Survey Instruments. So Vid, welcome to the webinar, and maybe just tell our viewers something about yourself and your role that you play in 3D Survey.
Thank you. So I think a lot of people here already know me. So I'm Vid Peterman from 3D Survey. I'm CTO at our company, and I also handle a lot of support requests. So I see a lot of familiar names here in the chat section already. So 3D Survey is a photogrammetry software that enables getting accurate 3D results out of the images. So I think we'll do for a quick demonstration, and we'll see more about it later during the presentation. So today I'll be here to answer your questions if there are any. I'll be also taking care of chat section. So if there are any questions, you can go ahead and ask them here in chat, and we will try to answer them in time. And I think at the end of this presentation, there will also be a short Q&A session, so you can also save your questions for that time. So, okay, back to you, William.
Great, thank you, Vid. Thanks. Yeah, so very important what Vid mentioned is to make notes. So get your pen, make notes, and send us all your questions at the end of the webinar, and we'll try to answer them as best as possible. So let's go over to Leon from Some Survey Instruments. Welcome, Leon.
Awesome. Thank you very much, Vian. Yes, guys. So as Vian mentioned, my name is Leon Malan from Some Survey Instruments, and we are really excited for today, because part of our motto is trying to help you be more profitable. And that is part of what this webinar is all about. So it's some new technologies and new ways to do work more efficiently, better, and at the end of the day, save you a lot of time that can obviously add into making more profit on your projects and in your workspace. So yeah, get ready, and we are really excited. So as they said, take out some notes and let's start. So I'm going to walk you through a quick overview. So the main purpose of this webinar is to provide practical training that you can apply in your workspace and achieve the same results. So we are quickly going to go and take and look at the problem and the solution. So exactly why we are here, and then on how we can actually solve that problem. Then we're going to look at the equipment and the software that you will need in able to solve the problem. Then Viam is going to take us through the training. So that's why we're here, to take us through step by step onto how the physical field training would look like, and as well as the 3D survey part, and training you exactly on how the 3D survey post-processing of this as-built of the building is going to look like. And then at the end, we're going to also have a chance for some questions and answers that we're going to try to answer live, as well as we're going to introduce a special offer that is only going to be available for the webinar attendees. So make sure that you stay until the end. So looking at the problem, so why are we here? There are many situations where 3D models are a crucial part of a project. With an accurate 3D model as data, you can achieve much more in less time at a reduced cost. Problem is that it has always been either too difficult or too expensive. Traditional methods of collecting, rendering, and storing survey data are rapidly being replaced with 3D digital data scanning and modeling. Today, three-dimensional surfaces and objects are converted into highly accurate mathematical representations using drones or laser scanners and post-processing software. Thanks to the benefits of 3D laser scanning and modeling, building environmental professionals enjoy an easy, independent, and cost-effective resource for mapping any type of surface. So guys, today, contractors, engineers, architects, and land surveyors all use data modeling. Traditionally, when creating a model, they start by scanning the area to be modeled with 3D laser scanners. The modeling process can be used for a lot of things. So as you guys would know, so let's name a few. 3D BIM modeling, 3D topographical site scans, 3D site representations and modeling. So construction as built, and that's actually one of the examples that we're going to go through today. Measurements for erosion control plans, grading volumes, height measurements for equipment and crane mobilization, environmental compliance, surveyed contours, volumes, and cross-sections, and then also 3D modeling also provides for fast data collection and increase in safety and in difficult environments such as valleys, quarries, landfills, and facility locations. So we know why 3D modeling is used. The main problem is that it has always been either too difficult or too expensive. Traditional laser scanners cost a minimum of $30,000, which is about 500,000 Rand. And that's just for the physical equipment. So what's the solution? Well, the phone in your pocket paired with the SOMGO and 3D survey post-processing software, allowing you to achieve the same results, but at a fraction of the price. So guys, I think before we carry on, let's just look at some polls and maybe ask a few questions. It's always really great to get to know our viewers a bit better. So the first question is just maybe share in the chat, share in the comments area where you are from. So what country or city you're from. So let everyone get a feel of where in the world are you tuning into. Awesome. So I see we have Zaid from India. And we are also obviously from South Africa. There's someone from Croatia and Belgium and Mauritius. Welcome, guys. Yes, Algeria. A few South Africans. Yeah, Germany. So you have a few Europeans here with us. Namibia. A lot of South Africans here. Hi, guys. Awesome. Germany again, Kenya, Chile. Yes, we're almost from all parts of the world. And different weathers, huh? Okay, awesome. So next up is a poll. So guys, just maybe indicate what industry are you from. So you will see that there's going to be a poll and you can just select an industry. Okay, so surveying and architects. There the data is coming in.
Engineering, construction. Great, guys. And also just make sure if you can't see the poll, please send it to us in the message section so that we can try and help you with troubleshooting.
Okay, awesome. Yeah, so you can see, so the majority is actually surveyor. And then we have engineering, architect, construction. There's a few GIS and also a few other industries. So we'd actually be very interested in what the other industries might be. So in the comment sections, just maybe write your industry as well. We'd love to know that as well. Okay, awesome. So to carry on. Okay, so let's quickly look at the equipment that you're going to need in able to get the result that we are after. So firstly, the phone in your pocket. So a lot of people are asking what type of phone can be used. So the answer is quite simple. Any modern smartphone with a decent camera. It can be iOS or Android with enough hard drive to download our surveying app. But obviously, guys, it goes without saying that the better the device, the better the operational experience would be. But it does not necessarily mean that not having a high-end smartphone that you wouldn't be able to gather the data needed. And also, the next thing that you're going to download on the phone is our SOM app, the Surveys on a Mission app. So our surveying app allows you to take the picture and store the precise location generated by the SOM Go. What this is it replaces the mock location of the cell phone with the centimeter accurate location that's generated by the SOM Go. So unfortunately, our app is still in a beta version, but it will be available early next year. In the meantime, you really don't have to worry. There is a simple workaround to still get the desired results. Awesome. Okay, so next up is the SOM Go. So the SOM Go, so you would attach your phone to the SOM Go. And in essence, the SOM Go is a small portable device enabling you to obtain centimeter accuracy regardless of your industry. And as we just saw there, there's multiple industries attending the webinar here today. So this little surveying GPS connects to your phone that you would use as a controller, turning it into a portable, handheld, multi-band receiver. It can either connect to your local interrupt station or to an RS2 GPS base station to get its corrections. So let's take a look at the specs of the SOM Go. So guys, if you are in an open environment, you can get a fix in under 5 seconds. But because it is multi-band frequency, so that means it gets its corrections from multiple satellites, that you can even get a fix in quite dense environments as well. It has interrupt and VRS capabilities, enabling you to an RTK distance up to 60 kilometers, PPK and PPP up to 100 kilometers. And then it outputs a Bluetooth NMEA stream. So what that means in essence is that it can really work with any type of third-party software. Awesome. Okay, so carrying on. So let's quickly look, before we jump into the training, just look at the results and an overview of 2 case studies. So the first case study that we did was the accuracy test. So everyone's question is, how accurate is the SOM-Go really? So let's look at this case study. First test was to compare the SOM-Go's accuracy to a reputable multi-band RTK GNSS receiver. We did 4 measurement sets in total. In the case study, we walk you through each one, comparing the data to the first set of positions captured being the baseline. For the webinar, let's jump to the results. So guys, as you can see there is our 4 sets of measurements that we took. So we took actually quite a lot of points with each, in each almost situation. So, but looking at the results, so we compared the RS2 baseline measurements with the SOM-Go on a GPS pole, and that one came in under 1 centimeter difference. It was only a few millimeters difference. And then the SOM-Go device in hand, so going down on your knees and taking the measurement, that result came in under 2 centimeter of difference, which is actually really, really good. You can also download the case study. So you'll see there's going to be a quick pop-up, and we're going to share the case study with you guys. So you can just click there and you can download it, and it's also available on our website. Awesome. And looking at the second case study we did was the SOM-Go photogrammetry case study, which we did with 3D surveying. So what we did here is we took photos of a building. We compared the actual measurements of one of the bricks to the measurements of that same brick processed out of the photos using, in option A, a cell phone's internal GPS, and option B, the positioning of a cell phone paired with the SOM-Go. So looking at the results, the actual brick measurement was measured at 21.7 millimeters. The brick measured in 3D survey using the SOM-Go came in at 21.4 millimeters, where the measurement with the cell phone was 15.1 millimeters. So that says that the SOM-Go was accurate within 3 millimeters. That is a 98.6% accuracy compared to the 69.5% of only using the cell phone. Later, you will see how the SOM-Go's accuracy actually increases with a bigger measurements, even up to 99.9%. So again, guys, I'm going to also share this case study, so you will be able to download that as well. It's also going to come up there, and you can download the case study and just go view the full case study and go read through the case study and to see the full results as well. Awesome. Okay, so now that we know the SOM-Go and the equipment is really accurate, and that the physical equipment is actually going to help us achieve the desired result, and that is creating the 3D model. Next up, we're going to look at how the model would be processed, which is 3D survey. And Vid, we're going to ask you here to just tell us a bit more about 3D survey in terms of processing and a bit of the history, and yeah, before we jump into maybe another poll and then almost time for the training. Thank you, Vid.
Sorry, Vid, I don't know if your mic is on.
I'm sorry. I just muted my microphone. So thanks, Leon, for giving me the word. So 3D survey was developed we started developing it about 6 years ago with the purpose to make a software that will be oriented for surveyors. So it's a software made by surveyors for surveyors. And we try to add into the software functionalities that are useful for land surveyors, like most are here listening to this presentation. So we have integrated CAD engine, high quality point cloud, and these kind of things in the software. So the typical workflow for this kind of instrument will be you just import the images. You do first step of bundle adjustment, so that we already calculate positions from where the images are recorded. Then the data will be automatically referenced to the GPS data recorded by the SOMGO receiver. And out of this data, we will create point cloud, 3D mesh, and maybe even an orthophoto. So then after that comes CAD engine, where we can draw some CAD lines, we can make some volume measurements, we can make X-ray image out of it to make simple 2D maps and so on. So maybe now Leon can show the next part of the presentation.
Yeah, perfect. Thank you so much, Red. I think we'll go over to a poll so we're going to start a short poll. And if you can maybe just answer the questions on the poll, and we'll just have a short discussion about that. Right, so the poll question is, do you have any surveying experience? So you can just go ahead and say yes or no, maybe some just a little bit, basic measurements, but not really a lot. So just go ahead and answer those. Don't be shy, don't worry, it doesn't matter what you select. We're all here to help you, so it does not matter what you select. Okay, just give it maybe 10 more seconds. See, there's still some people answering. Okay, great. Thank you, guys. Thank you for your collaboration in working and just answering the questions. So I think let's just go on to the next phase of the webinar, which is the training part. And I know this is what you guys have been waiting for. So thanks, Leon, for all the information. I hope you guys have really found the information useful. If there was any questions that you guys are too afraid to ask on the live chat, please send us an email, and we can obviously have a discussion about that as well. Or we can just have a telephonic call or Zoom meeting, whatever the case may be. But please remember to take some notes now. We're going to start with a short training video now. So write down your notes, and at the end we'll answer all your questions and see how good it was.
Ever wondered how to create an accurate 3D model using your phone? Today we're going to show you how to create an accurate 3D model and compare it to the original as-built of a building. Let's talk about the scope of work. We've got two primary objectives here today. The first one is to measure the contours of the entire site to determine where the stormwater flows and if the original stormwater design is sufficient. The second objective is to create a 3D model of the front face of this building. Let's talk about the equipment you'll need. Today we'll use the SOMGO connected to the nearest Entrip station using your cell phone at hand. If you do not have a local Entrip station, you can always set up the RS2 as your own personal Entrip station and get a distance of up to 60 kilometers working with it. Or alternatively, you can link the SOMGO with the RS2 on a normal LoRa radio connection. The first important step before we start with our task for the day is to make sure that we calibrate or use the existing control on site as what we have found here. This is the original control point which was used to establish and set out this entire building. we're going to make use of that and do a site calibration and make sure that we work from the correct and same coordinate systems. To do this, we want to be as accurate as possible when we do a site calibration as well when we measure the contours. In order to do that, I'm going to link the SOMGO with a 2-meter pole. The first thing we're going to do is take off the original antenna from the SOMGO. We'll now go into the box and get out our 5/8 thread that will go on top of our pole. The next thing we'll do is connect our antenna to the adapter. We'll now go ahead and screw on the adapter onto the pole. Great, let's connect our SOMGO. We want to make sure that we screw it nicely on top of the connection, and then we can now go ahead and extend our pole. We're going to go ahead and do a site calibration.
Connection is successful. Fixed.
Great, so we've done our site calibration. Let's go ahead and do the contour survey. The way we're going to do this is, as we can see, there's quite a steep hill coming down. So in order to get the best accurate contours, obviously we have to start at the top and work our way down to get the full slope of the water and how the water will flow essentially. So let's go to the top and start. Great, so we measured our first point. Let's go ahead and measure a 5x5 grid. Because this area is so small, we're going to keep it to 5x5 meters. If this was a bigger site area, we would have extended the grid to a 10x10 or even a 20x20 meter grid. It's always important to look back to make sure that you are following a straight line when you want to walk your correct grids. It's not essential, but it's always cleaner when you look at your data. Great, so we completed the contour survey. We cannot get points close to the building due to fixed roof, which we have to work under. So what we'll do is, when we do our 3D model, we'll just extract the points at the bottom of the garage doors. We will do this to complete the contour model. Okay, great. So we've done our contour survey. Next thing we want to do is capture the photos for this 3D model. The first thing we have to do is we have to turn our device in a horizontal position, like that. Because we know the offset from the antenna to the center of the camera, we've already typed that in and we're going to work from there. Very important to remember is that we want at least a 70% overlap in each photo. What that means is that when you take your first photo, you want at least 70% of that first photo contents to be visible in your second photo. So let's go ahead and go to the second photo. Great, so to create the best possible model, I've identified a distance that I need to be from the building, which will be able to accurately get all the data, the full spectrum and size of the building. I will continue and maintain that exact line until the end of my survey. I'll also make use of equal steps to make sure that my data overlap is correct and maintains a 70% overlap. So we've completed the scope of work. The next thing we need to do is to just double check our site calibration by going to the exact same points, taking it out and taking a measurement, making sure that there was no shift in the data. After that, we can pack up, head back to the office and start 3D survey to start with the processing.
Sorry guys, I see there's some technical difficulties. We'll just try and replay the video quickly.
Ever wondered how to create an accurate 3D model using your phone? Today we're going to show you how to create an accurate 3D model and compare it to the original as-built of a building. Let's talk about the scope of work. We've got two primary objectives here today. The first one is to measure the contours of the entire site to determine where the stormwater flows and if the original stormwater design is sufficient. The second objective is to create a 3D model of the front face of this building. Let's talk about the equipment you'll need. Today we'll use the SOMGO connected to the nearest N-trip station using your cell phone at hand. If you do not have a local N-trip station, you can always set up the RS2 as your own personal N-trip station and get a distance of up to 60 kilometers working with it. Or alternatively, you can link the SOMGO with the RS2 on a normal LoRa radio connection. The first important step before we start with our task for the day is to make sure that we calibrate or use the existing control on site as what we have found here. This is the original control point which was used to establish and set out this entire building. We're going to make use of that and do a site calibration and make sure that we work from the correct and same coordinate systems. To do this, we want to be as accurate as possible when we do a site calibration as well when we measure the contours. In order to we're going to go ahead and keep it to 5 by 5 meters to a survey. We cannot get points close to the building. When we do that first photo contents to be visible in your second photo. So let's go ahead and go to the second photo. Great, so to create the best possible model, I've identified a distance that I need to be from the building, which will be able to accurately get all the data, the full spectrum and size of the building. I will continue and maintain that exact line until the end of my survey. I'll also make use of equal steps to make sure that my data overlap is correct and maintains a 70% overlap. So we've completed the scope of work. The next thing we need to do is to just double check our site calibration by going to the exact same points, taking it out and taking a measurement, making sure that there was no shift in the data. After that, we can pack up, head back to the office and start 3D survey to start with the processing.
Okay. Great, guys. I don't know if you guys managed to finish the video. Just maybe give us a yes or a no in the video comment sections if you did manage to finish the whole video. Okay, great, but not a problem. We'll release this video as well on an email letter later. So if you did miss it, don't worry. We'll just continue with the webinar and you can always watch this at a later stage as well. Okay, great. So I trust there was some new stuff that you guys learned. For those people that hasn't been in the surveying field, I think there's a lot of techniques and things that was very new to you. So yeah, I hope that was informative, and I think we'll go over to the processing side. So I just want to quickly do a quick poll and ask you guys, do you have any photogrammetry experience currently? So you can just maybe say yes or no on the... Yes, thank you guys. All right. So after this, we'll jump into the processing side of this, which is also still a small video, which we compiled. So again, please just take notes and we'll answer all your questions at the end of the video. So, but this one is a bit lengthy, but yeah, just try to stick with it and ask the questions. Even in the chat sections, we'll try to answer it, and also at the end of the webinar. Okay, awesome. Thank you, guys. Yes, which is about 52%, and
Hi, and
no,
welcome
about
to the 3D survey
22%.
part of this
And
training.
if the guys that have some experience, about 25%. Okay, great, guys. So, thanks.
In this part of the training, we'll show you how to create a new job and how to import all your photos into the job, as well as add some telemetry data and check your accuracies of your telemetry data manually. Let's go ahead and click on New Project. Now we will navigate to the desired folder. As you can see, it's Webinar, and we'll go and locate the photos inside of the folder. We'll select all the photos, click on Open. Great. Now we'll go ahead and select the EXIF data of the original photos. We'll say Import, and as you can see, the data is imported successfully. We click on OK, and there you can see the coordinates as it's listed. You've got the lat long coordinates with the height as well as the X, Y, and Z coordinate. The current precision and accuracy is set to 10 meters. That's because it's using the internal accuracy of the device that was used, and we need to go and set that manually. So we'll click on Manual Precision, and then we'll enter the accuracies that we think will be sufficient, and for this model we think it will be 0.05 meters, which is 5 centimeters. Once we updated the correct accuracies, we can now import the physical new telemetry data. So we'll go search for the file, click on Browse, and go locate the file, say Open. And the next very important step is to select comma and not semicolon, as this is a CSV dataset. And now we can go and physically label our columns. So the first column is your image name. Very important is to see that you got a .jpeg file, and the name of the image must be exactly the same when you use this telemetry importer. If it is not exactly the same, it will automatically give you an error when you want to import. So really important to make sure that your name is 100% the same. Now we'll just go and allocate the rest of the coordinates as X, Y, and Z. And we'll just make the coordinate system to be known to zone 36 south, which I think we are currently in. And then we'll re-import our physical telemetry data. As you can see, there's our new coordinates, and we are satisfied with that. There will be no error currently, as we have not done a bundle adjustment. So there will be no error, but as you can see, there has been 224 images has been imported with physical coordinates and telemetry data. So a very important step is your camera parameters. Over here you can save your camera parameters once you've done one set of processing. Because we have done one set of processing using this exact camera, we can go and locate the saved file. This will just make the model automatically a bit more accurate. And you can do this for any camera and just save it under a specific name, and make sure that when you use that specific camera that you use those camera parameters. Click on OK. Great. So the next important part is to click on bundle adjustment, and this will give us a sparse point cloud, and then allowing us to see some visual data of what we can expect in our full point cloud. So as you can see, there's 3 steps. There's bundle adjustment, orientate, and reconstruct, and we'll go in and just click on bundle adjustment. For this data set, we'll click on hybrid, as it will be the best, as it's incremental and global. So that means that we'll get the best desired result. Also, we'll change the settings to generic,
and important is to use the telemetry data. So over here we'll just increase, so we'll make the maximum feature detection to be about 50,000, just to make sure that we detect enough features. And then we'll also make the feature detection level too high. Once we're done with that, we can go ahead and click on OK. Just to give you some extra feedback why we use the high method for the feature detection, it's just because we are using a normal camera phone and not a drone camera, which means that we would like to get some more data out of this data set to make sure that the accuracies are as good as possible. In a normal drone data set, we would have kept everything as it was, but for this specific one, we'll just go ahead and change it up and down a bit. So the bundle adjustment step will just help us get a sparse and basic point cloud, as I've mentioned before. So we'll just let it run through. Great. So as we can see, we've got about 2 minutes left for the bundle adjustment, and then we'll recap. Once we're finished with the bundle adjustment, we'll go to reconstruction, and then we'll compare some contour lines and import the as-built and maybe do some comparisons on the as-built as well. Great, as you can see, the bundle adjustment step has finished, and now we can have a look around into the bundle adjustment and see what a sample or space point cloud looks like. As you can see, you can get a basic idea of what's going on site. We can see more or less where the building is located. We can see some clear parking bays, see some trees. We can see trees on the outskirts, as you can see there. And we can see, some small window detail, and we can see the clear parking bays, and there's some small trees as well. So really good. And now we can look at the error that was determined from the bundle adjustment step. As you can see, mostly I would say it's about 3 centimeters error across all the images, which is relatively fine. This is a mean error in my X, Y, and Z. So I'm pretty satisfied with that, and I think that result came out fine. Great, so we can see that there is a bit of a basic outline on our site, and we can also see those light blue icons on the screen is where our camera positions were. So we're pretty happy with what we are seeing currently. Great, so as you can see, there's a great outline of our site, but I think to get a better idea and to see that what we are seeing in our sample or space point cloud is relevant to what we have seen on site, it might be a good idea to maybe jump to some of the images and see if we can correlate what we are seeing as what it was on site. So I'll just be clicking on one image, and there you can see a basic outline of what we saw on site. And I think that is really a close proximity of what we can see in our space point cloud, and I'm really excited to see how the final results of this point cloud will look. I think we'll definitely like to capture some points from that side and maybe to the other side, and also some garage positions, maybe the corner points and so on. Would like to draft that in the CAD and then compare that to the as-built and to the design and see what the results might be and might look like. There we can see we're satisfied with our model. Since we're satisfied with the model, let's go over and reconstruct this model to see some great detail. We'll just make sure that our graphics card is on and being used in the processing, and we'll use the reconstruction level. Medium will be sufficient for what we want out of the data set. I'll go ahead and press on OK. Great, so the reconstruction phase will take quite an amount of time, so we'll continue with the training once the processing has been done. Okay, great, so our processing is finished, and this looks like a pretty good model. As I can see, there is a bit of noise, but still really satisfied with the point out. It's about 16.5, almost 6.6 million points. And that's good enough for us to get some great results and desired results from this specific data set. Also, just in terms of survey, each point that you see out of the 16.6 million points would have always been selected or measured physically with a total station. So as you can see on this wall corner points, for example, those are a selection of 100 points that I can detect and select for a specific corner point, whereas those points would have been had to measure with a physical total station. So really great how technology has improved our lives. Great, and also as we've seen on those pictures, you can see how beautifully this facade has been processed, and we're really satisfied with the way it came out and the result looks at the end of the day. We can really see some great corner points of the buildings, nice and clear detail on them, which means that if we have to draw the points, we'll be able to do that as accurate as possible. So there is still a bit noise, but not as much as we would have thought. Great, and as you can see, the paving is really processed well. There's some stormwater outlets there, and we can really see the type of detail that we're able to get even on the plants specifically. So we'll just try and maybe zoom in on some plants and see if we can see some more detail, but as a whole you can see that we're really satisfied with the results at the end of the day. I think this point cloud will be sufficient for the type of data we want out of it, and we can even maybe draw some garage corners and get some great building detail out of this and be able to compare it to the physical design, which we'll do later in this training. Also, a very important aspect of this training is to see the accuracy on the positioning of the camera as well as in the height as it was processed. Well, we'll be able to detect this is we took some GPS points across the site, as you have shown you in the previous field training part. So we'll go ahead and compare that data with what we have processed and see physically how accurate this data has been. Great, so I think for now, maybe a good example to go further will be, I'll use the scan functionality and go to polyline to be able to draw some lines. And you can also create a point manually if that was your preferred method. So to create points on the corners, export those points, or you can physically draw them while they are there. A very important part of this webinar is that we would like to measure the as-built of this building from this line and compare the design or the as-built to the original design and see how accurate the model was, as well as how accurate the physical building was built. Doing so, we can make sure that everything was built to the specific design criteria that was approved from the council. The first thing we'd like to do is to make sure that we can select a corner point. As you can see, that point is on the corner as close as it can be, and we'll go to the other corner and just make sure that it's 100% on the side of that corner of the building. And as we can see, it's really on the edge, which is exactly where we want it to get the full dimensions. You can now see that this line length is 13.328 meters. When we look at the original design, we can see that the physical length is 13.340 meter, and we can see that it's taken from the outskirts of the corners of the building. So that means that our line has got a deviance of about 12 mil according to this sketch. Just to zoom in and make sure that the dimensions are correct. So that's 13.340, and let's go back and see what the exact comparison was in 3D survey. And as you can see, this was from the left corner to the right corner on the extremities, and that brings us to the side distance. So 12 millimeter deviance just shows you how accurate the SOMGO can be when you combine it with 3D survey software. And I don't think that anybody that has taken photos with a device has been able to get this type of accuracy out of their 3D model. And this just shows why it is so important to have a tool like this in your arsenal to get this type of data. Great, so I think we arrived at the point where we are now able to do some classification and get some contours out of the site and see just how accurate we were able to do the processing, and how accurately we can compare the data set to the original GPS data that we also captured on site. So that will be a great comparison that you'll do very soon. Great, so without further ado, let's jump to the classification. And as you can see, there's already default settings for the ground classification, which should be sufficient, especially for most of the type of jobs. So the next thing we can do is just click on next and then select the physical ground which we want to classify. And as you'll see that the model will automatically detect only the ground points, and we can then generate some contours. I'll go ahead and click on the ground. And as soon as I click on the ground, you'll see that it is a slight light red shade. And this was the automated detection, which the software detected, which is ground points. Those other ones that are on the roof will be eliminated now soon, as they don't fall within the criteria. So, as you can see, they are correct now. And we're very satisfied with the classification that has happened here. As you can see, under all the trees inside that walkway that has gone underneath the building, and also underneath the trees there's classification. So it means that our contour model will really look complete compared to our site, and this is satisfactory to what we want to achieve and be able to compare to our GPS data that we have compared and got on site. Let's just go ahead and rotate the model a bit to see what has been classified. As you can see, some of the grass has been eliminated, but that's fine. We don't really want the plants to be part of our contour model. The low-lying grass is fine, but everything higher we don't really want part of our contour model. You see there's some classification happened at the back there, which is really great, as that's accurate data that was processed. So really satisfied. Great, so in order to move to the next step, we must remove the other, which is the unselected points, so that we can just work on the contour file. As it's now, if we had to create a contour, it would have taken all the buildings and everything into account. But as soon as we delete other, that has been eliminated, and we can just work on our physical ground profile, which is what we want for our site. Great, as soon as we press delete other, you'll see that all the other points have been deleted and removed from our site, and we can just see a physical ground profile currently of our site, which will be used to do our contours and to generate our contours. But that gives us a great idea of the ground profile. And as you can see, even those points at the back, which was selected in the passage, is still really relevant to our ground profile, which is great stuff. We first have to create a mesh. So let's go mesh and calculate a new regular mesh for DSM. We'll keep it to 0.1 meters for my grid cell size, and we'll go ahead and just calculate it. As you can see, there's a basic mesh. Some of those outside extremity points might give us a bit of a problem when we calculate our DSM model or our contours. But we'll see how it goes. Let's go ahead and calculate contour lines. As you can see at the bottom right side, there's a calculate contour lines. And now we'll select the interval. So you can make this interval anything which is relevant to your site. I think for this site, we might select 0.25, as it will give us a better fall of the water, for example, and better data to be able to compare it, because it's a very small site. I also think this will give us a great indication as to which direction the water is flowing. Let's click on continue. As you can see, there's our basic contour model, and there's a few extremities which we don't really necessarily want as part of our model, as it's not really relevant to our area of interest. It doesn't make a difference to it, so we might just go ahead and delete those points. But the outskirt data looks pretty fine, just shows how accurate our model is. So really satisfied with the type and the flow of this contour. You can have a better view of our contours once we select contour lines, and we can now view it and physically see how the contours were calculated. We can see that the plant's error did have a small effect on the contour line, but I think for this example it's fine. You can also see the stepping of the contour lines there as it stepped on the 0.25 meter intervals, which is great. In order to really compare these contour lines, we'll go ahead and import the GPS data set that we have taken on site, and we have created an additional DXF model from that. So we'll just go to data and load that CAD data and see how it compares to what we have had on site. We'll just quickly navigate to the folder. There we go. We can just select it and open it. The DWG for the contours that we've measured with the GPS. And as you can see already, it's overlapping very well to our existing model. And we can really compare some points manually with this, but so far we can really see a good comparison from the DXF data that was imported onto the point cloud. As we can see here, the data points that was imported all have heights. So a good example and comparison will be to take those existing GPS measured points and measure them with what we have had and what we have processed the heights to be. So let's go and do some real data comparison. And also, as you can see, that those blue lines are from our GPS data, but they are very, very close to our processed contour lines. As you can see there, they are very, very close and very similar to what we have retrieved on site. I think for us to be able to accurately compare the data is to maybe start from a side and then work our way through the field and do some spot random checks, maybe in the shade areas which would have been difficult to process or where errors might creep in, and also normal proper visible areas, and see how the data compares to that. So for this we need to go and select CAD and then select points. First we need to make sure that our mesh is turned off. So let's go to mesh and just turn our mesh off, and we can return to our point cloud and use our CAD functionality again. We'll go click on CAD, point, and this will give us a live comparison of how accurate and what the difference between our GPS data and our process data was. As you can see here, I'm just trying to get it as close and as best as possible, but that looks to be about, say, 3 to 4 centimeters in vertical accuracy. And this is not bad, considering that this is almost some of our outskirt points on our point cloud. So let's go ahead and do some more comparisons quickly. I think let's move over to a point in the shade and then just see what type of accuracy we could have expected out of the shade area. So let's just try and get it as close as possible. Oh, that's good. So that's, let's say, under 10 mils for a shade area processing, which is perfect. And that just shows you why you must use a SOMGO in the field. Let's go over and get some more data points comparisons and see what we can get accuracy wise. And then, as you can see over here, that is 1 foot 8.05, so that is again less than 10 mils, so meaning centimeter accuracy once again. Let's maybe go ahead and compare another point, maybe in the middle, see how it compares. Oh, great, so that looks like about 10 mils, so that's still
Hey William, I think you also have to turn on your microphone.
Can you guys hear me?
Yeah. No,
Okay, sure. Sorry. So thank you guys for taking that time. I trust that this was really some good information and a good small tutorial that you guys could have seen and maybe can use in the future. Let's just talk about 3D survey. I see there is quite a lot of questions from the guys regarding 3D survey, but as a registered surveyor, I can just say that 3D survey has improved the way we do surveying, and the program is solely built by surveyors for surveyors. So it does not necessarily cater for all the different aspects and fields, but it's really extremely good in surveying related, photogrammetry requests. So I think I've got another small video just about 3D survey that might answer more about 3D survey as a whole. So we're just quickly going to play that. That's a small, short 2-minute video, and then we'll recap and then go to the questions and answer section of the webinar. Great, guys. Okay, great, guys. So I think that answers a bit more questions about 3D survey as a whole. And we can also just elaborate a bit more. So that video was more about drone surveying, but that's exactly what 3D survey can also give you, the ability that it has to give you. So when you combine 3D survey with a SOMGO as a handheld GPS receiver, you've really got something which you can use in the field, which is fast and effective and gives you great accuracy results. So I think as we go through some of the questions, I see there's still some questions coming in, but let's go to the questions and answer sections. So you guys can maybe post some of your questions. You can also send us a private message and we'll discuss about it and have a small discussion about it.
Yes, awesome. Thank you very much, guys. Yeah, so as Viam said, so post your questions, and this is now a chance that we can see the most commonly asked questions. Viam would then answer your question live if your question are chosen, and then if we did not choose your question or did not answer your question, you are again welcome to email us, and we will definitely come back to you. So just we're going to, while we are going through the questions answers, we're also just going to go to the special offer. So we're going to show you now, guys, the special offer. So you go into the web page of the special offer. So it will just open another browser, and you will see there that at the moment 3D survey is really on a great price, guys. So you'll see there's 20% off a 3D survey, and also a percentage of for all the SOMGO units. So when you go and you maybe you add 3D survey with one of the SOMGO units, you can actually use one of these codes. So you can use the SOMGO 5 code to get an extra percentage off the SOMGO unit, and also use the code webinar FS for shipping. So then you will get 50% off shipping, and that's only for the first 10 buyers. So yes, guys, but let's carry on so you guys can take a look at that, browse through the offers. Let's go into the questions and answer section.
So I already see that Mr. Reitz Beckman has asked a question. So he's asking if we can show him how the points are exported out of the SOMGO.
Awesome. I see there is a few people that is already using 3D survey.
So
maybe I can just I'll try to show him here on my screen. I'll turn screen sharing on.
Sure.
Allow. So here, I think this is this is a file how the points are exported out of SOMGO. So you get a text file, and this one can easily be imported into 3D survey then.
Yes, guys, exactly that. You get a normal CSV data set, which you can import into and use for your new telemetry instead of using your old telemetry on your device or your phone that you have used to take your pictures and do your survey.
So yeah, you have all the relevant information in here. You have image name, X, Y, and Z coordinates. So, and this is exactly what we need in order to get a good 3D model.
Yes. I think very important, again, just to mention, is the .jpeg extension file. If that is not there, you'll get an error, and this will not allow you to import your new telemetry data. So always important to make sure that the names are 100% correctly.
Okay. So Rice is asking, without 3D survey and photos, only the points. So he's asking how the measured GPS points are exported.
So we export it via CSV or text file. Both formats you can use in any CAD-related program, so the most or widely known, and we stick to those two basic export functions. So CSV and text format.
Okay, now Michael Mini is asking, can you export to Revit? CSV can be imported to Revit, but you need to remove the name to work with this. Okay, you could easily remove the name like that. So that would be the simplest solution. But I guess you can also export points and point names to Revit. So Revit is a software used for architects. So I think there are many ways how you could get these points into Revit. Maybe it would make sense to make a DXF file out of this and then export those points to Revit or something like that. So I think there are a lot of options how you can get this kind of data into Revit.
Definitely, I think if you use some other software as well, you can, as you've seen in the video where we imported the other GPS measured contour lines, which was calculated in another software, and we were able to import that data. So I think you can also follow the same workflow when you use the Revit and so on. I think they also recognize the same type of format, and you'll be able to utilize your data in the same way. Okay, great, guys. I think so.
So Right is again asking, what can be exported out of SOMGO app?
So at the moment, just the two exporting options are available, the CSV and a text file. So you can't export a KML or shapefile or anything like that. It's just the basic CSV and text file that you can currently export. The same with importing as well. You can overlay a KML file and stuff like that on your map, but just for importing, and exporting is definitely just a text file and CSV data that you can do.
Okay, and another question, I think I also know the answer for this one. So can some go receive corrections from the other GPS bases as well, like 3Dmodel base, for instance?
Yes, yeah, so it can definitely, depending if you want to use it on the same frequency, like a radio connection, then no. But if you want to use your Trimble base as an interrupt station, or you want to connect to a Trimble interrupt station, then yes, definitely you can. That can work.
Okay. Idris is asking, can we get the broadcast after completion of the course? Of course. We'll make sure that the recording is available for you to check it out later.
Yes, definitely. Now, guys, so if there's any more questions you guys have, you're more than willing to send us an email, or welcome to send us an email, and we'll try and get you all the information that you require. Also, we've got a back office on our website where all our training content is available. So on every purchase, we provide you with a full training on our back office, which you can watch and use. And that's like your physical guide. It's us in person with you, even though we're 1,000 miles away. So that's really great. So you can just watch your videos, follow the on-screen instructions, and we try to enable you to get the same results as what we get. And if there's some content that we do miss, we update it frequently and make sure that you get the best available content which we can provide you guys.
Awesome. Yes, thank you very much. And we just want to show you guys again. So in terms of, let's quickly start in terms of the coupon code. So again, so at your checkout, it will still be available for a little while. These coupon codes, you can use SOMGO5. So that's if you purchase a 3D survey as well as any one of the SOMGOs, as well as to get a bit extra of the shipping as well. You can use Webinar FS. You can add both of those two coupon codes in there. And yes, but we just really want to thank you, everyone, again for attending this webinar. The recording of this webinar will be sent to you via email. You'll probably receive it tomorrow after everything is done processing, and it will be available up until Friday. So you will have up until Friday to show a few colleagues and also just go through the training content again, because knowledge is power, and the more you look at something, the more you take in. Yeah, again, thank you from our side, from some Survey Instruments side. Really, thank you very much for attending this webinar.
Awesome, guys. Thank you guys so much. Thank you for your time. And we trust to see you soon in the future.
Awesome. Bye-bye.
Cheers.
Bye-bye.